Okay, listen dear students. In the last class, we are discussing about that solid state level 2 class 5 questions objective. Already how many questions are completed ma? 12 questions are completed. Okay. Let's see next 13th question. See from 13th question onwards. The 13th question, what they gave ma? See, in hexagonal close packing structure. 13th question. Let's see. Hexagonal close packing structure of spheres. The packing fraction of volume occupied by the sphere is A. Means A atoms are in HCP. Hexagonal close packing structure. Its packing efficiency, percentage of packing efficiency. Percentage of packing efficiency is equal to percentage of packing efficiency is equal to how much mass? 74 percentage. Packing efficiency is equal to 74 percentage. Okay. Now in that, in a cubic closed packing structure, B atoms present in cubic CCP, cubic closed packing structure, or FCC, face centered cubic closed packing structure. Their packing efficiency, percentage of packing efficiency is equal to 74. So what they are asked, the relation between A and B. In hexagonal closed packing structure of spheres, the packing fraction of volume. So packing fraction or packing efficiency of A and B. What is the relation ma? A and B. A is equal to B. So the correct answer is first one. Means the packing fraction of HCP, hexagonal closed packing structure, as well as CCP, cubic closed packing structure, or face centered cubic closed packing structure, the packing efficiencies are equal. That's why A is equal to B, because the A atoms are in HCP. Its packing efficiency is equal to B atoms present in FCC. Its packing efficiency both are equal. So correct option is first one. Let's see 14th question. In the 14th question, what they gave ma? In a structure, A atoms have FCC arrangements. Means A atoms are present in FCC, face-centered cubic crystal. Then the number of A atoms, number of A atoms is equal to Z is equal to 4. So what is the unit cell constant for face-centered cubic crystal? 4. So A atoms how many came? 4 came. Now the B atoms occupy all the tetrahedral sites. B atoms present at tetrahedral whites. TV tetrahedral whites. How many B atoms? Number of B atoms is equals to number of tetrahedral whites. How many number of tetrahedral whites are present? 2 into Z. So the number of tetrahedral whites is equal to double the number of atoms, is equal to 2 into 4 is equal to 8. So the B atoms how many are present? 8 present. Okay, C atoms occupies the half of the octahedral whites. C atoms present in 1 by 2 into octahedral whites. OV means octahedral whites. Then the number of C atoms is equals to Z by 2. because the number of octahedral whites is equal to Z. There are only C atoms half only present, then Z by 2 is equals to 4 by 2 is equals to 2. So the formula of the compound means the simplest ratio A is to B is to C is equal to 4 is to 8 is to 2. Then the simplest ratio is equals to 2 is to 4 is to 1. So the formula of compound is equals to A2 B4 C. Now the correct answer is second option. Okay, so A2 B4 C. How we derived that A2 B4 C ma A atoms are present at FCC. Okay, it is clear. That's why number of A atoms is equal to 4. B atoms are present at tetrahedral whites. That's why number of B atoms is equal to 8. 2 into 4 is equal to 8. C atoms are present at half of the octahedral whites, means 4 by 2 is equal to 2. So that ratio, simplest ratio is equals to 4 is to 8 is to 2 is nothing but 2 is to 4 is to 1. Then the molecular formula of the compound or formula of the compound is equal to A2B4C. A2B4C. Okay. It's very clear. Let's see the 15th question. In the 15th question, in a hexagonal closest packing in 2 layers, one above the other, the coordination number of each sphere will be. See, first we'll draw the hexagonal closed packing structure. 15th question, see the hexagonal closed packing arrangement, how it will be present. Like two hexagons are present, this, and exactly it will be matches. Like the hexagons of corners, how many corners are present? 6 corners are present. At 6 corner atoms are 1 atom, 6 atoms are present here. One center of the hexagon, 1 atom is present. Here 1 atom is present, and in the middle 3 atoms are present. Body center 3 atoms are present. So this is A layer, this is B layer, and A layer. This is the HCP. Hexagonal closed packing structure as AB layer arrangement. AB layer arrangement. Okay, it is very clear. Now in this any 2 layers, first 2 layers means AB layers. Let's see that one atom is surrounded by, this middle atom is surrounded by 6 hexagon corners and remaining 3 total. So in 2 layers, coordination number in hexagon is equal to 9. But the coordination number of HCP, hexagonal closed packing structure, is equal to 12. In between 2 layers, the coordination number is 9. And number of atoms present in HCP, unit cell constant Z for HCP is equals to, so total 12 hexagonal corners are present, then 12 into 1 by 6 plus 2 face centers are present, 2 into 1 by 2 plus 3 body center atoms are present, 3 into 1, then is equals to 2 plus 1 plus 3 is equal to 6. So HCP, hexagonal close packing structure, the unit cell constant is 6 and HCP coordination number is 12, but in between two layers, the successive layers A and B, two layers, the coordination number is 9. So the correct answer is fourth one. The correct answer is fourth one. Okay, let's see. The next one, 16th, is direct theoretical. 16th, in close packed lattice contains n particles or n atoms are present. So the number of atoms present in unit cell is equal to Z is equal to how many they gave, n value they gave. According to that, number of tetrahedral whites. TV means number of tetrahedral whites is equal to 2 into Z, means double the number of atoms is equals to 2 into n, means 2n. Number of octahedral whites, OV, is always is equals to Z, its unit cell constant, is equals to n. So the correct answer is the tetrahedral whites are 2n and octahedral whites are n. When the unit cell contains n atoms or n particles, n atoms or n particles are present, then the number of tetrahedral whites are 2n, octahedral whites are n. Let's see the 17th question. 17th question. A body-centered cubic solid is made up of two elements, means BCC crystal structure. Two elements A and B. So the BCC, body-centered cubic crystal, has two elements. Two elements A and B. What are the two elements? A and B are present. Okay. Two atoms. The A atoms of A occupied the two corners of the cube. Means A atoms only present at two corners. Two corners, its contribution is equal to, at each corner the atom is present, its contribution is equal to 1 by 8. 2 into 1 by 8 is equals to 2 by 8. Okay, it is very clear. Now the B atoms are contributed at the remaining portion or remaining positions, means remaining out of 8 corners, 2 are occupied by A, the remaining 6 corners plus body center. Body center is equals to 6 corners, 6 into 1 by 8 plus body center 1, then is equals to 6 by 8 plus 1 is equals to 6 plus 8 by 8 is equals to 14 by 8. Now A is to B. A is equals to how much? 2 by 8 and B is equals to 14 by 8 is nothing but 2 1 7 times, means this is A is to B, the simplest ratio is equals to 1 is to 7. So the formula of compound is equals to A1B7. A1B7. So is nothing but AB7. So the correct answer is third option. Third option is correct. Okay, students. Let's see next questions. The next one, 18th question. Let's see. It's very easy, 18th question. Sodium Na and tungsten W and oxygen, 3 atoms are present in one unit cell. Then what is the formula of the compound they're asked? If you are observed that in the given question, a solid has a structure in which W atoms are present at are the located at the corners of the cube, means the number of W atoms. 8 corners are present and each corner contribution is equals to 1 by 8, then W atoms is equals to 1. Okay, let's see. W is over. Next, oxygen atoms are at the corners of the edges. Edges. For example, you have to think about that. This 19th question, how many edges are present? Like this is one edge, 1, 2, 3, 4. Upside 4 edges. This right side, this downside 4, and this 2 and this 2. Total 4 plus 4 plus 4 is equals to 12 edges are present, ma. So the 12 edge, each edge contribution is equals to 1 by 4. Then is equals to the oxygen atoms are 3. The oxygen atoms are 3 because a cube has 8 corners. Okay, it is very clear. A cube has 8 corners and 6 faces. Okay, 6 face centers or 6 faces are present, and 12 edges and 1 body center. One body center is present. That corner contribution is equals to 1 by 8. For each atom, corner contribution is equals to 1 by 8. At each face, the atom contribution is equals to 1 by 2. At each edge, each atom contribution is equals to 1 by 4. And body center contribution is equals to 1. So according to that, the W atoms are present at corner. Then the total number of W atoms is equals to 1. The oxygen atoms are present at edge centers. Then total 12 edges are present. Then the total oxygen atoms are 3. Now the sodium atoms are present at the center of the cube. Means the present at center of the cube, only one center is present. Then 1 into 1 is equals to 1. So the formula, the simplest ratio of sodium is to tungsten is to oxygen is equals to 1 is to 1 is to 3. Then the formula of compound, the formula of compound is equals to NaWO3. NaWO3. Okay. So the answer is NaWO3 means third option is correct. Okay. Let's see 19th question. The 19th question. Observe carefully, ma. The 19th question, what they are asked. See, in the given one structure, a cube they given like this. There contains M atoms. This M atoms symbol is like this is the M atom symbol. And X atoms also be present. That X atom symbol is dot. Now, in this, what is the formula of the compound they gave? If you are observed that the M atoms where they present, ma, they are present at 4 edge centers. Edges, 4 edges plus 1 body center. Okay, 1 body center is present. If edge center, then its contribution is equals to 4 into. If edge center is present, its contribution is equals to its contribution is equals to 1 by 4. Edge center is present, its contribution is equals to 1 by 4 plus body center is present 1 into 1. Then how many, ma? 2. M is equals to 2. Now let's see X. The X are present at corners. These all are the corners. Now me. Okay. The X atoms are present at corners and as well as face centers. How many face centers are present? 6 face centers are present. Plus face centers. Face centers. So corners, 8 corners, each contribution is equals to 1 by 8. 6 face centers, each contribution is equals to 1 by 2. 1 plus 3 is equals to 4. Now the simplest ratio m is to x is equals to 2 is to 4. That is nothing but 1 is to 2. The simplest ratio is equals to 1 is to 2. Therefore, the empirical formula is nothing but simplest ratio of the compound, or simplest ratio of all atoms in a compound is known as empirical formula. So formula of mx is equals to m1x2 or mx2. So the correct answer is second one, mx2. The correct answer is a second one. Understood? Okay, let's see next question. 20th question. In the 20th question, what they asked, see, the percentage of white space in metallic elements crystallizes in ABC type of lattice pattern. Means ABC, ABC layer arrangement. Layer arrangement present in FCC, face center cubic crystal structure. We know that FCC, face center cubic crystal, its packing efficiency, percentage of packing efficiency is equals to 74%. So 74% is packed, the remaining is empty. So void space, void percentage is equals to 100 minus 74 is equals to 26%. Okay, so 26% is a void, 26% is empty. So the correct answer is second one. The correct answer is a second one. Let's see next, 21. Question. If A stands the edge length of a cubic system, okay, so what is the radius ratios of simple cubic and body center and face center, they ask. So we know that in simple cubic crystal CCC, radius relation 2r is equals to A, then r is equals to A by 2. The radius of simple cubic crystal. Okay, A is equals to, R is equals to A by 2. Next, what they are asked, simple cubic. Next, body center. Next, face center. BCC, body center cubic crystal system. In the shortcut relation, 4R is equals to root 3A. Okay, from this, radius of atom in a body center cubic crystal is equals to root 3A by 4. Okay, next in FCC, face center cubic crystal, the relation 4R is equals to root 2A. This you remember, this 3. According to that, we can write easily edge length and radius relation. So in this, radius is equals to root 2A by 4, then 4 is nothing but 2 into 2, then 2 is nothing but root 2 into root 2, then root 2 will cancel, A by 2 root 2 will comes. So the radius ratio radius ratio in simple cubic crystal is to body center cubic crystal is to face center cubic crystal. FCC is equals to a by 2 is root 3 a by 4 is a by 2 root 2. So the correct one is third option. Third option is correct. So the radius ratio in simple cubic crystal and body center cubic crystal and face center cubic crystal is a by 2 is to root 3 a by 4 is to a by 2 root 2 a by 2 root 2. Okay. Next, let's see that 22 question. The 22 question. A compound contains two atoms. X atom is present and Y present. So in that X atoms, it crystallizes in a cubic lattice with X atoms at the corners of the unit cell, Y atoms at the body center. Then the simplest formula they are asked. So X atoms only corners. Corners means how many corners are present? 8 corners, but each atom present at corner, its contribution is equals to 1 by 8. Then the number of X atoms is equals to 1. Y atoms are present at body center. Body center. Then how many body centers are present? 1 only present. Its contribution is equals to 1. Then number of Y atoms is equal to 1. So X is to Y ratio is equals to 1 is to 1 only. Then the formula of compound. Formula of compound is equals to XY, because the simplest ratio of X is to Y is equals to 1 is to 1 only. Then the formula of the compound is equal to XY, means third option is correct. Third option is correct. Understood? So next 23 question, let's see. Twenty-three. 23 question 1. The total volume of atoms present in face center cubic FCC. It's very easy. FCC, face center cubic crystal, Z is equals to 4, means 4 atoms are present. So in FCC, 4 atoms present. Four atoms present. So the volume of 4 atoms is equals to 4 into the volume of atom. Volume of each atom means you have to imagine that atom is in a sphere. Means the sphere volume is equals to 4/3 pi r cube. So 4 atoms volume is equals to 16 by 3 pi r cube. So the correct answer is fourth one. Next 24. 24. The packing fraction of total volume occupied by the atoms present in simple cubic crystal. So in simple cubic crystal, SCC, simple cubic crystal contains only one atom is present, that is equals to 1. Its packing efficiency is equals to volume of one atom, volume of one atom by volume of cube. Volume of one atom is equals to 4/3 pi r cube by volume of cube. All edge lengths are equal, then it is a cube. But in simple cubic crystal, in SCC, we know one relation, 2r is equals to a, then r is equals to a by 2. So in this r place you substitute a by 2. Then we'll get 4 by 3 into pi into a by 2 whole cube. by a cube. This a cube will cancel. Okay, 2 power 3 means 8 is nothing but 4 into 5 pi by 3 into 8. Then 4 1 ja, 4 2 ja. Then the answer is pi by 6. So that is packing pi by 6 value is approximately 0.52. Then percentage of packing efficiency is equals to 0.52 into 100. Then we'll get 52 percentage. So in this question up to this only they are asked according to the options the answer is pi by 6. The answer is pi by 6. Okay, let's see that 24. In the 24th question, what they are asked, ma? Sorry, 24th is over. Next, 25th. 25th question, a metal crystallizes in face-centered cubic lattice. The edge length of the unit cell is 408 picometers. The diameter of the metal they are asked. So, diameter in FCC, we know that in face-centered cubic crystal, 4R is equals to root 2A. It's very clear. Diameter is equals to 2R is equals to root 2A by 2. Okay, then is nothing but root 2 is nothing but 2 root 2 into root 2 is nothing but root 2 into root 2. Then one root 2 will cancel. A by root 2 will comes. And A value they given 408 picometers and root 2 value 1.414. On simplification we'll get approximately 288.5 picometers. So the correct answer is first one. Okay, so diameter is nothing but what, ma? R plus R is equal to diameter. So from the diameter, radius do you want means diameter by 2, then radius will get. Okay, let's see next question. Semiconductors, ma. So silicon. So overall I will explain you the 26th question. Silicon and germanium are called semiconductors. In pure state, semiconductors conductivity is known as intrinsic semiconductors. Then intrinsic semiconductors conductivity is very low. Then we have to add some impurities. Impurities that is known as doping. Addition of impurities to the pure silicon and germanium is known as doping. Okay, so the doping elements, what are the doping elements we are adding? One is 5th A group elements, the second one is 3rd A group elements. 3rd A group elements valence is trivalent, means 3 valence electrons are present in its valence shell. 5th A group elements valence is 5, it is pentavalent impurities. So 3rd A group elements means boron, aluminum, gallium, indium, thallium. If we are adding these 3rd A group elements impurities, then those are called p-type semiconductors. P-type semiconductors. Okay. Next, instead of p-type, then if you are adding that impurities is nitrogen, phosphorus, arsenic, 5th A group elements, antimony and bismuth. Okay, then we'll get n-type semiconductors. N-type semiconductors. See here, silicon and germanium. To germanium, they are added for making of p-type semiconductors. Which impurity we need to add? Trivalent impurities. Trivalent impurities means boron, aluminum, and gallium, indium, thallium. Okay, pentavalent impurities we are adding, then we'll get n-type semiconductors. N-type semiconductors. Keep it in your mind. And semiconductors conductivity is increases with increasing temperature. But metals metals like electronic conductors, that conductivity decreases with increasing temperature. Okay. Next, very, very important ma, just direct concept, that is 27. See the 27th question, the purity of metal, the purity of metal, purity of metal can be detected by the ratio of specific conductance at 300 Kelvin to the ratio of specific conductance of metal at 4.2 kelvins is known as it gives this value, the ratio of specific conductance at 300 Kelvin and 4.2 kelvins. That value, this value gives the purity of metal. If this value is more, then the purity of metal will be increases. This value is less, then the purity of metal will be decreases. Next, 28th question ma, wrong statement. Actually correct in the question, which of the following is correct statement they're asked. It is not wrong ma. So which of the following is not correct statement, that we need to identify. Silicon is doped with boron, means third year group elements, then we'll get p-type semiconductors. It is correct. The silicon is doped with arsenic, nitrogen, phosphorus, arsenic, that is fifth year group element, then we'll get n-type semiconductor. It is correct. Metals are not good conductors of electricity. Metals are not good conductors of electricity. Generally, metals are the good conductors of electricity. So here not good conductors of electricity they gave, mean this statement is incorrect. Now, electrical conductivity of semiconductors decreases with increasing temperature. This statement is also incorrect. Actually,